I'm currently working on a custom car audio build that features a full DSP amplified 5-channel system, and I need to make this amplifier rack. But there is a challenge here. Can I make it so that this whole amp rack and subwoofer enclosure can be easily removed from the vehicle for extra trunk space, and then have the factory head unit power the speakers again just by disconnecting and reconnecting a few plugs? So here is what we have in store for mounting on our amplifier rack today. First of all, we've got a JL Audio Fix 86. This is an OEM integration DSP. This is going to flatten the factory signal coming out of the vehicle. So we'll be feeding the OEM speaker level signal into this, and this is going to give us RCA line level outputs and allow us to retain the front to rear fader. And we're going to be sending that signal to this, the JL Audio VX1000/5i. This is a 5-channel amplifier, so it's going to give us 4 channels of speaker output and then 1 channel for our subwoofers. And this amplifier is a little bit more unique because it has these kind of like pigtail style connections. So we're going to have to think through how we're going to mount everything to our amplifier rack using these. Now for physically wiring these items together, we're going to be using wiring from our show sponsor, New Concepts. I've been using New Concepts for many years, long before I even started the channel. They have a wide variety of different wire and wiring accessories. In this case, we're going to be using some of the Colossus Flex cable for our power wire. Normally, I would also use these New Concepts crystal RCA cables for sending signal between the different devices, but I don't think we are going to need to use these in this build. More about that in a second here. But we'll also be using these basic fuse distribution blocks. These can be used in both a power and a ground configuration by using these ground links. To learn more about all the different wiring and power distribution options from New Concepts, check out the links down in the video description. Now, I also have some LGDs. These are load generating devices that we're going to be using in front of the signal for the Fix 86. We'll talk about that more in a second. And then I also have some quick disconnect plugs. In this case, these have 8 different pins that we can use. And the reason for these is I want to challenge myself on this build to actually make it so that we can easily completely remove the whole amplifier rack out of the vehicle. But not only that, I want to design the wiring in a way that when we do unplug our aftermarket system, we could just plug these plugs back together and send the OEM signal out of the OEM head unit to the aftermarket speakers straight from deck power. So we definitely have a lot to do here, and we're going to kick off the process with actually making the board that everything is going to mount onto. So this here is a piece of 1/4 inch thick HDPE. You could also use 1/4 inch ABS. That's a common plastic type to use. Doesn't really matter. Both materials kind of work the same way. ABS you're going to be able to bond to a little bit better if you do need to glue anything in place, but we'll do mechanical mounting means on this HDPE, and I've already cut this to the general size that I'm going to need. If you haven't been following along on the build, this is the custom subwoofer enclosure, obviously right here. It's got some beauty panels on it, but if we flip it around, on the backside here, this is where the amplifier rack is going to mount. Now I've made these standoffs that sit off of the box. That helps isolate the amplifier rack a little bit from the box, but it also gives us some clearance behind the amplifier rack that we can use for our zip tie heads. More on that in a little bit, or if we did need to potentially run any wiring from the back and come through the amplifier rack to the front. Although I've cut this piece on the table saw to the overall rectangular size of this, I do want to cut off these top corners just so that we have proper clearance into the vehicle and so that it matches the box. Although I could make those cuts on the table saw, I actually prefer to make preparations for cutting these on the router. The reason being, it does take quite a bit of setup time to make sure you hit your line perfectly using a miter gauge over on the table saw. And even when you do take that time to do that setup time, I find sometimes it's not perfect. I can make sure I get a perfect result by using a straight edge template here. And then I'm just going to use a flush trim bit over on the router. In this case, to be more particular, we're using a 1/4 inch spiral flush trim bit. You can see it's got the bearings on the top there, the spiral cutters on the bottom, and I do need to lower this a little bit just so that the bearings ride against my template and cut the piece down below. Now our shape matches nicely, but something you're going to notice when you're working with plastics is sometimes you get kind of this rough edge depending on what different router bits or table saw blade you're using. In this case, you can see It left a little bit of those rough edges with the router bit, but also on this cut here that I made earlier with the table saw. So we want to clean that up, and we also don't want these edges to be sharp anyhow, so we can use a router bit for that. I'm going to use this guy here. This is a mini 45-degree chamfer bit from our other show sponsor, Mobile Solutions. They have a wide variety of different router bit solutions for custom fabrication. This is the other thing that's cool about using a router table. You have flexibility for different bits that you can use. I'm taking out a 1/2-inch collet right now that would be used with a 1/2-inch sized bit, and these smaller bits have a 1/4-inch size shank here, so I'm going to use a 1/4-inch collet. Get that loaded in, tighten it up. Off camera, I've also used this Mobile Solutions Smart template to add a 1/4-inch radius to this bottom corner here. Overall, using that along with these chamfers has given this a nice finished feel. Now I need to drill all of the mounting holes that are going to mount my board to the enclosure here. All of these are 2" by 2 inches, so to hit the center of them, I need to go 1 inch from each side, so it's going to be easy for me to lay out all of these holes. So this is one of the fasteners that I'm going to use to hold the amplifier rack onto the enclosure. This is a 1024 bolt, so I need a 3/16 inch through hole drilled in this plate. After making all those holes in the amplifier rack, I'm using this. This is a transfer punch, and that allows me to transfer the exact center of each of these holes to the enclosure. With all those spots transferred, I am now going to make holes using a 7mm bit, which is the special bit size needed for these threaded inserts. These inserts are going to thread down into the wood. Doing this gives me a permanent machine style thread that I can then use for this 1024 fastener. Once added, they look a little something like this. I like to take a sander and quickly sand those just to make sure everything is nice and flush. But you can see this gives us some nice machine threads that we can easily fasten into and take this on and off as many times as we want without degrading the quality of that hole. Did a quick little test fit here of all the screws just to make sure everything is lined up like we expected it to, and we are good to go. Now remember, it's a good idea to do this mounting step before you do any of the wiring, just so you know where the holes are going to be that you need to avoid. Obviously, you wouldn't want to have any wiring going in front of any of these or having any of the different components blocking out these different holes. To prepare my work area here, what I've done is I've taken a couple of scrap pieces of wood and I've template taped them to my table. That way I just have a little bit of a spacer here and I don't have to work on this while it's on the enclosure itself. But that little bit of space is going to allow me to drill through without damaging the table, and I can tap holes as needed, drill holes for zip ties, etc. Now, after spending some time kind of moving things around, this is the general layout that I've come up with here. I'm going to have all of my power distribution on this side, and that's going to allow me to keep the power distribution away from any of the signal wires. I'm going to come up around here, go into the amplifier. I'm also going to have a separate smaller lead that is going to go over to power the Fix 86. I obviously need a signal connection between the Fix 86 and the VXI amplifier, which I've established here. And then I need signal coming into the Fix 86. For our source signal, we're going to have our plug right in this location here. It's going to go into the load generating devices. It's then going to go into the Fix 86. And for our signal outputs coming out of the amplifier, we're going to have a permanent connection for the subwoofer because this is mounted to the subwoofer enclosure. But for the connection that we need to disconnect to remove everything as a whole assembly, I'll have a separate plug for all of these speaker wires. Now, a couple of different tools we're going to be using here. Again, we'll be using a set of transfer punches. This allows us to mark the exact center of the different mounting holes for all of our different devices. And once we've marked that center hole, we can use a drill bit to drill a hole and then a tap to add threads. So just to give you a real quick example of what this looks like with mounting these New Concepts basic fuse distribution blocks, you can see I'm using that transfer punch and then the drill and then the tap. It's as simple as that to add a threaded hole that I can use machine fasteners to attach everything to this board. In the meantime, I also drill and tap the holes for the amplifier and get that mounted in place. In this case, I switched to using 832 fasteners because that's the size I needed to go through the through holes on the amplifier. I then mounted the Fix 86, and you can see that the RCA wires are connected when I was planning out where this was going. That just is because I can't really change the length of these connections to the amplifier. The Fix 86 was also mounted using 832 fasteners. Now, up until now, everything has been mounted with a mechanical fastener, but I also need a way to secure these LGDs in place, and in this case, I'm going to be using some zip ties. After carefully doing my layout there of where they're going to go and drilling each of these holes, I can then apply the zip ties, and I want to make sure that I have the head of the zip tie on the back side of the panel. I can then flip over the panel assembly as a whole and use my flush cutters to trim those away. So I now have these rigidly mounted, and again, that's the reason for having this 1/2 inch space behind the panel and between the subwoofer enclosure itself. It allows room for some of the fasteners to stick out slightly if need be, but also for the heads of the zip ties. So now that everything is physically mounted, we need to connect the wiring between all of these different devices. So cue up the music montage. A quick update here, I made a small mistake and I just wanted to point it out to you guys so that you guys don't make the same mistake. So when I made this wire, this twisted wire here, I only did 2 conductors for positive and negative. And the reason I did that is I was thinking that I would have my remote lead also be a temporary disconnect here on the power wire and come through here and just go to the amplifier. But then I realized that I actually want my remote lead to go to the Fix 86 first, and then I'll have a remote out, which will go from that to the amplifier. So for that reason, it's probably better if I make this a 3 conductor run. So I'm gonna unsolder this from my little smaller fuse block here. I'm going to obviously remove the ground wire here and just make a new connection, but otherwise we'll redo what we have here. I'm just gonna have an extension of a blue wire that goes over to here so that I can have a quick disconnect for that as well. And here we go, guys. About 5 minutes later now, I've added that additional conductor, making a new bundle here, and that's going to give me my remote lead that's going to run over to the Fix 86. This is obviously one of the advantages of making your own bundles of primary wire like we did here. Now I need to start securing this wiring to the amplifier rack. I'm going to use the same strategy that we used to mount these. We're going to drill some holes at an even spacing through our amplifier rack and mount with zip ties. Throughout this process, I'll be using the D wire ruler from the guys over at 5 Star. I'll be using this to get myself even intervals quickly and easily without taking the time to actually measure. Now for our speaker wire harness, I mentioned this earlier, but I want to use one of these quick connect harnesses. If you want to learn about these in detail, I did a full separate video, but the quick synopsis is basically you have a male and female side, and these have pins inside of them, and we're going to essentially crimp these little connectors onto each of the wires and add them into these plugs. So the VXI amplifier has all of these pigtail connections that we mentioned earlier. We're using these ones to send signal in, but we do have a set of other inputs that we don't need. We have a set of pre-outs that we're not going to be using in this case that we might be using in the future. On these extra connections, I could theoretically just cut these away to keep everything nice and clean, but I don't want to mess up this connector here. So instead, what I came up with is this little 3D printed solution. Here, this has some little tabs down here that can separate the different wires. I made it with 5 so that I could use this file on other ones in the future because there's 6 of these, and at minimum you're going to be using at least one of these connections, so that's why I left 5 on here. But basically I can tuck the extra wiring into this, and I've given myself some more mounting holes, and I can mount this onto the board. Here's what it looks like installed, so nice and clean, keeping those unused wires out of the way. If you guys would like one, message me via the website. I can make one for you as well. So with that, my friends, we now have everything completely wired up and ready for installation into the vehicle, but let's do a quick review. First off, remember that this is going to be attached to the subwoofer enclosure, and we're able to meet our goal of being able to easily and quickly remove this from the vehicle and wire back in the factory head unit to the speakers. We can do that because you can see that we have these 2 plugs here. This is going to connect to the signal coming from the factory head unit, which will have this plug here. And then this is the signal coming from our aftermarket amplifier, so our amplified signal going to all of the speakers through this harness here. To quick disconnect power and ground, I was able to find this cool coupler online. I'll put a link for you guys down in the video description, but this quickly separates as well and includes the remote wire connection. So we would disconnect the power and ground and then disconnect our signal plugs. And what's cool is because of the way I've wired this, we could take the signal coming from the OEM head unit and plug it right back into the speaker wires, thus powering the speakers with the factory head unit. Signal path wise, once we come from from the factory head unit, we go through these wires into the load generating devices. That way the factory head unit isn't going to mute because it doesn't see the speakers connected anymore. These kind of simulate a speaker, if you will. The signal is then going to go into the Fix 86 and be corrected. That's going to give us a nice flat clean signal out that we can then send into the VXI amplifier and completely DSP, tune, and control. The amplified signal then, of course, goes out to all the speakers along with to the subwoofers. Now, taking a look at our power distribution, power and ground wise, here we have our power distribution block. We have an 80 amp fuse and we have a 15 amp fuse. The 15 amp fuse is the smallest I could find for the mini A&L size, and I only need technically a 1 amp size fuse. So I step down here to a small little fuse holder, and that's going to give us our power for the Fix 86. Obviously, the larger power wire is giving us our power for our amplifier, and both devices are connected via this ground distribution block to the ground of the vehicle. We, of course, also have our remote turn on lead that comes all the way over to here. It's going to turn on the Fix 86, which will then have a delayed remote output to turn on the amplifier itself. If you enjoyed this video, I'd appreciate a quick smash of the like button. And if you guys want to learn more about car audio electrical system design, or if you want to see my other amplifier rack wiring videos, be sure to check out the related videos. To get power wire and power distribution parts for your next car audio project, be sure to check out our show sponsor, New Concepts, at the link down in the video description. A big thanks to them, along with Jerry and the rest of the Patreon membership team, for making these videos possible, and thank you guys for tuning in and watching.